In this video, we will learn to take angles such as these, and we will sketch the angle in standard position, and we will give two positive and two negative coterminal angles, and we will also state the reference angle for each one of these. Look at 5 pi over 6. This is one of my special angles. The special ones are pi over 6 and pi over 3 and pi over 4. And also pi over 2, though that sort of falls into its own category. So when I look at any ones that are my special angles, then the first thing I do is I take my circle and I divide it up into pieces that have this size. So if here's my circle, then if I make a semicircle, then the top half is pi. Alright, pi radians. So if I want pi over 6, 1/6 pi, then I'm going to have to divide the top half into 6 pieces. So far I've divided it into 2 pieces. So what I do is I further divide it like this. So you see I have 3 pieces here. I do it again. So now the top half has 6 pieces. That means each one of these little slices is 1 pi over 6. That means 5 pi over 6 would go like this. So understand that standard position always starts here on the positive x-axis. Okay, and if we go the positive direction, we're going counterclockwise. So that's 1, 2, 3, 4. No, 1, 2, 3, 4, and 5 pi over 6 would land right here. So this would be the angle in standard position, and the arrow that I drew is part of the sketch. Alright, let's move on from there and talk about 2 positive and 2 negative coterminal angles. So you can get a positive coterminal angle if you pick up from here and go all the way around the circle and come back to where you started from. In other words, if you add 2 pi, you'll get a coterminal angle. So I'm going to add 2 pi to this, and it should be another angle that's landing on the same spot. And you could view this as 2 pi over 1, but hopefully you understand that we need like denominators. So if we do 6's, then what we're really doing is adding 12 pi over 6 now. Okay, so maybe I can just rewrite this and go, okay, so this is 12 pi over 6. Now 5 pi over 6 plus 12 pi over 6, that is 17 pi over 6. Okay, so that'll be one of my coterminal angles, 17 pi over 6. So if I take that and I add another 2 pi to it, that'll give me another positive coterminal angle. So again, this is like 2 pi over 1. So again, 2 pi is the same thing as 12 pi over 6. So maybe I can just modify it. Alright, so I'm adding 2 pi, but I'm calling it 12 pi over 6, so I have like denominators. This is going to be 29 if you add 17 and 12. So this is going to be 29 pi over 6. So I'm just going to erase this and put 29 pi over 6. So those are our 2 positive coterminal angles. All I did was I added 2 pi twice to the original angle. So if I want some negative coterminal angles, then I'm going to subtract 2 pi and see what happens. So if I subtract 2 pi, and by now you've picked up on the fact that 2 pi is the same thing as 12 pi over 6, so I'll just go straight to that. So 5 minus 12 is negative 7, so this is negative 7 pi over 6. So that is a negative coterminal angle. So I'm going to copy that down. Alright, negative 7 pi over 6 is my first negative coterminal angle. Now for another negative coterminal angle, I could subtract again another 2 pi or another 12 pi over 6. Now this is going to make negative 19. Alright, negative 7 and negative 12 make negative 19 pi over 6. So that this would be another negative coterminal angle. Alright, so I'm just going to recopy that. So negative, wait, this color is not going to be visible enough. Stick to the program, Burton. So that's going to be negative 19 pi over 6. So there you go, 2 positive and 2 negative coterminal angles. Now we need to state the reference angle. Well, when it's one of these special angles, okay, this doesn't really apply to pi over 2 because pi over 2 means you're right on the axis, and when you're right on the axis there are no reference angles. But when you're one of these 3 denominators, your reference angle is just one of these. So my reference angle for 5 pi over 6 is just going to be pi over 6. Alright, if it was 7 pi over 6, it would still be pi over 6. So there's my reference angle. It will just be pi over 6. Okay, that's just too easy for words. Now it's been a long time since we've looked at degrees, but it's not too tough to switch our brains back because we spent most of our academic career so far learning in degrees. So let's reminisce and remember how degrees used to work. So first let's sketch the angle in standard position. So here's my circle. Now let's talk degrees. Remember that all the way around a circle is going to be 360 degrees. So we're talking about an angle that is bigger than 360 degrees. So keep that in mind. So how much bigger, by the way? Well, we'll figure that out as we go. So standard position is going to be like this, alright? So if I went all the way around and back to where I started from, so far I've gone 360 degrees. Okay? Now if I picked up from here and went to here, that's another 90 degrees. Alright, so 360, hold on, let me try that again. 360 plus 90, that's 450 degrees. So I'd be looking at 450 degrees if I went this far. But that's too far. I only want to go to 420. Notice that the difference between 420 and 360 is 60. Okay, so that means if I go 60 more degrees past 360, that will be 420. So you know, so it's going to be somewhere in here. You know, it's just 60 degrees in. Alright, so there's my drawing. So I'm ending up in the first quadrant here. Now, let's talk about positive and negative coterminal angles. Well, I sort of just found one positive coterminal angle, a smaller one, which is also going to be the reference angle. So I just found that if I go 60 degrees, just the short way, not all the way around and then 60 degrees, that's going to land me on the same spot. So there's one coterminal angle is 60 degrees. And in a minute, they're going to ask me the reference angle. And that's also 60 degrees, because the reference angle is always the angle that you're making against the x-axis. So this 60 degrees right here is also the reference angle. But if you didn't realize about the reference angle being a coterminal angle, you might have just added 360, because that's one way to get coterminal angles, is just add the entire circle. So 420 plus 360 is 780. So that's a positive coterminal angle. If you add another 360 to that, plus 360, that's 1,140. Why'd I put 2 commas? I don't know. So here are 3 positive coterminal angles. Now if I want some negative coterminal angles, I need to subtract 360. Now of course, as we saw already with the reference angle business, if I subtract 360 that first time, wait, short memory. Yeah, so if I do 420, hold on, let me get a fresh, clear screen. If I do 420 minus 360, that's a positive angle still. And that's why I was able to include it in my list of positive coterminal angles. So I'd have to keep going from here if I want the negative one. So I could subtract another 360, and that's negative 300. So that's a negative 1. Alright, if I want another one, I will subtract 360 again. So negative 660. Alright, so there are 3 actually positive coterminal angles and 2 negative coterminal angles. So that more than satisfies what we were asked to find. And we already mentioned the reference angle, so we're good on the 420. Okay, let's talk about number 3. 17 pi over 12. So that's not one of our special ones, so this was going to take a little bit more work. Now it would be helpful to know exactly how many pi this is. In other words, focus on this part, 17 over 12. Let's turn this into a decimal. 17 divided by 12. Okay, so it's about 1.4 pi. Okay, so this is approximately 1.4 pi. So this is going to help me to do my sketch. Okay, I messed up and it moved. So let me just draw that again. Okay, so here's pi. Okay, so this is pi right here. Okay, you could think of it as 1 pi. Now, right here, this is 1.5 pi. So it's 1.5 pi. So you see I've got 1.4 pi. So that means this angle is going to fall somewhere in this third quadrant between 1 pi and 1.5 pi. Probably fairly close to 1.5. But the main thing is getting the quadrant right. So it's going to be somewhere in here. Okay, and if I start off in standard position, then I'm talking about this. So this would be a sketch of 17 pi over 12. Alright, if I want a positive coterminal angle, I need to go all the way around and back to where I started from. So that's why I'm going to add 2 pi to this. You can think of this as 2 pi over 1, but I need like denominators, so I need this to be a 12. So you understand that what I'm going to do is I'm going to multiply by 12 in the numerator and denominator. So that's really going to make this 24 pi over 12. Okay, so hopefully you don't mind if I just erase that and put that 24 pi over 12. Alright, so that is 41. So this is going to be 41 pi over 12. So that is a positive coterminal angle. Okay, if I want another positive coterminal angle, I will add another 2 pi. Okay, but as we've already seen, 2 pi is the same thing as 24 pi over 12. So I'm going to do that again. 24 pi over 12. So that's going to give us 65 pi over 12. 41 plus 24 is 65. Okay, so 65 pi over 12. So if I want a negative coterminal angle, I need to subtract 2 pi. Okay, which is the same thing as subtracting 24 pi over 12. Now you could probably do this in your head, but 17 minus 24 is negative 7. So we're talking negative 7 pi over 12. Okay, so that is a negative coterminal angle. If I want another one, I need to subtract 2 pi again. So again, that means subtracting 24 pi over 12. Alright, so negative 7 minus 24, and I hope you don't need a calculator to do this. That's going to give you negative 31. Alright, so negative 31 pi over 12. Alright, so that's it. We found our 2 positive coterminal angles and 2 negative coterminal angles. Now all that's left is we are now supposed to find the reference angle. The reference angle. So look, the reference angle is always the angle that's measured from the x-axis. So in other words, this is the reference angle right here that I'm coloring in yellow. Okay, this is the reference angle happening. So that's what we are trying to find. So that reference angle is, alright, let me just get rid of this. You see that it's sitting here between 1 pi on the one hand, and on the other hand, remember that the problem, the original problem that we graphed here is 17 pi over 12. So let me just write that down. 17 pi over 12. So if I want to find this reference angle, I need to find the difference between these two angles. So the difference means I need to subtract. So I'll just need to subtract 17 pi over 12 minus pi. But let me do that over here. So I'm doing, okay, 17 pi over 12 minus pi, and this should give me the reference angle. But you know, this is pi over 1, and I'm going to need like denominators. So this would be the same thing as 12 pi over 12. Okay. So that's the same thing. So 17 minus 12 is going to be 5. So this is going to be the same thing as 5 pi over 12. So that is going to be my reference angle. Alright, so here comes the last one. Negative pi over 4. Let's do the sketch first. Okay, this is one of the special angles I was talking about. Alright, one of the 3. So when I see pi over 4, the first thing I do is I divide my circle into pieces that have the size of pi over 4. That's what I always do when it's one of the special ones. Okay, so far these are all half pi's, right? Pi over 2. So if I want pi over 4, I just need to split it again. Alright, so notice the top half is in 4 pieces, so each one of these is pi over 4. Now, I'm supposed to draw my angle in standard position. So standard position always starts on the positive x-axis. Because it's negative, I know I need to go in the clockwise direction. Alright, what happened to my initial side? Let me try that again. So I know I need to go clockwise because it's negative. And I'm going negative just 1 pi over 4. So I'm just going this way, just one position. So I'm ending up right here. So that's it. That's my sketch. Now, if I want a positive coterminal angle, I need to add 2 pi, as we've done before. So if I want to add 2 pi, okay, but yet I need like denominators, so I'm going to have to take this and multiply by 4. So that's going to give me 8 pi over 4. Let me just rewrite it. So 8 pi over 4. Now this is like negative 1 plus 8. So that's going to be 7. Alright, that's going to be 7 pi over 4. So that's going to be a coterminal angle. Now you can see that visually in the picture. If I just went the other way around, okay, it'd be 1, 2, 3, 4, 5, 6, 7 pi over 4. Anyway, so that's one positive coterminal angle, is 7 pi over 4. Okay. If I want another positive coterminal angle, I will add another 2 pi to this. So if I take this and I add another 8 pi over 4, which is the same thing as 2 pi, alright, another 8 pi over 4, well, that's going to be 15. 15 pi over 4. Alright, so those are 2 positive coterminal angles. Now if I want negative coterminal angles, I need to subtract instead of add. So I'm subtracting 2 pi, and we've already seen that 2 pi is the same thing as 8 pi over 4. So this is like negative 1 pi and negative 8 pi. So that's going to make negative 9 pi over 4. So that is a negative coterminal angle. If I want another one, I need to subtract another 2 pi, or another 8 pi over 4. Okay, so this is not a comma, this is me subtracting. Negative 9 and negative 8 make negative 17. So this would be negative 17 pi over 4. So those would be two negative coterminal angles. Now, because this is a special angle, stating the reference angle is trivial. Because for the special angles, you just look at the denominator and see how it's 4. Then the reference angle will just be pi over 4. So it really doesn't take any thought. And that is going to be a good place to stop this video.